All right, well, good morning, weather people. My name is Cameron Nixon, and welcome back to Mesoscale Musings. Today is Wednesday, April 22nd of 2020. It's actually the 10th year anniversary of a pretty widespread tornado outbreak in the western high plains. So we are inching our way toward a shift in our severe weather from the southeast, thankfully, after the year they've been having, and into the much sparsely populated as a whole central plains. So today we'll actually hold Oklahoma's first legitimate risk for some longer-lived supercells with the attendant threat for all hazards. The Storm Prediction Center has outlined much of this area down here and a risk for this is a level 3 of 5 risk, enhanced for all hazards, including large hail, strong tornadoes, in addition to damaging winds. So let us tackle the setup that this is going to occur with. Well, we have a mid-level positively tilted trough. Again, our supercells really do not care what tilt our trough is, and in many cases, this positive tilt can actually help us out a little bit. In the plains, you usually have a north-south oriented dry line, and we really do not like these more southerly flow regimes, this meridional flow, as this tends to keep our supercells kind of hugging that north-south line because they scoot them pretty close to its axis. Whereas if you get more of that 45-degree angle, you get your right splits to move out pretty perpendicular to that line. So this is a really good direction of flow that would support discrete supercells. This is pretty much ideal. Discrete right-moving supercells, I should say. So we can look at our vorticity pattern within this. Here's our vortmax here, and you've got some sort of advection, especially in the northeast quadrant. So I could expect this to move pretty much east-northeast throughout the day. And if we draw this out, this is essentially what happens. This kind of ambles its way across Oklahoma, especially the northern portions of it. Toward the lower levels, we have a kind of we have some pretty strong 850 millibar flow, still residual from the nocturnal jet, most likely. And you have some semblance of an advective regime with this. So I can get closer to some real-time obs. First of all, you could see the influence of a subtropical jet here with that kind of subtle upper level lifting along the kind of northeast warm conveyor belt kind of regime here. And so we could take a look at what that looks like. And sure enough, our friendly subtropical jet is actually over here producing some of those cloud patterns. As we zoom in a little bit more, you can see the entire state of Oklahoma is under some type of convection right now. Given that is the early morning hours, I am highly going to bet that this is elevated convection, and then we can discuss why that is if we zoom a little bit closer. Got a remnant kind of warm front, more of a synoptic warm front, especially from last night. So you got low to mid 60s dews underneath this. I'm seeing a couple 67s perhaps, 68 over 65 in Childress. And then we got, I believe this is Alta, 62 over 59. So a little bit of a temperature gradient here, not anything too sharp. A little bit more diffuse, but what's going on here is if we check out our low level flow, it is oriented perpendicular to this boundary that we just saw is kind of west to east. And so this little flow is just going to ride over this boundary and kind of ignite convection that kind of scoots around up top of that stable layer. So during the day, or during kind of from the early morning to noon hours, I'm assuming you get a pretty strong warmer advection regime to take hold. This may end up strengthening our low pressure a little bit at the surface, which we could check out its current status right now. So here's kind of our low location. This may end up strengthening throughout the day. I can kind of draw this out, and that's essentially sort of what happens, especially as it moves into northeast Oklahoma with the passage of that mid-level wave. And in tandem, that mid-level wave will likely strengthen as well. See a little bit of a height fall and kind of a broadening, more open trough pattern as we move toward the late afternoon. So that is going to kind of, that feedback is going to deepen the system as a whole. and perhaps even strengthen our low-level wind fields. We could check out how our low-level jet evolves throughout the day, and it looks like some portions, especially closer to the low, are able to kind of create a more enhanced low-level mass response that may help us increase our shear for the potential supercells we're going to have around here today. You could also see a tightening gradient on the southeastern edge of this low, coincident with an increasing wind field. We could check out, let's do relative humidity, and we've got some sort of kind of mid-level moisture plume here. And you could definitely see the mid-level convergence through this kind of like southeast gyre here, as well as the Pacific front out to the west, converging to create this sort of channel, which I have noticed in the last few events, and this is probably definitely a thing that is very common. I'm just learning about it now, especially through these discussions, and that's why these are very helpful for me, is that I'm able to pick out features like this that I didn't necessarily focus on before. Because we can see there's not really much of a surface pattern that is associated with these, so they're not extremely obvious features. And then I could go to theta E to further prove this. The dry line is back here, and this kind of low or just off the deck feature convergence zone is a little bit east of that. So the current status of our dry line looks like Lubbock is faithfully reporting its more westerly flow with lower dew points of around 49 degrees. Looks like we got our dry line somewhere around the Abilene area. That will likely sharpen up during the day as some of that stronger mid-level flow comes in over the higher terrain and kind of mixes down that warm, dry air to kind of scoot that forward. So again, with this kind of downslope flow regime, I would expect a surface dry line, which is currently kind of around or just east of Lubbock to the Abilene area, to sharpen up and scoot east throughout the day, which is it looks like it is going to be progged via the RAP model. So this is going to be an obvious initiating factor. We also have some semblance of a cold front that you're able to see on satellite, kind of this line right here, and you've got some northerly flow. This is just north of the OKC metro. So as this cold front dips down as well, this is going to pose a slight concern for convective mode, but also offer a potential triple point target, which we'll discuss. So the mode for the convection, again, we have the three regimes. We have this cold front, we have this dry line, and we have this convergence zone just off the deck. Let's check out the mode of this possible convection. So cold front is usually pretty obvious. We have a sagging boundary that is going to kind of scoop up our convection throughout the day. And then it is also roughly, if I throw up some cape and shear, it's also oriented roughly with the deep layer shear vector. So any updrafts that form along it are usually likely going to end up congealing into a line, as those updrafts, even in strong shear, are not able to move off that boundary and become right movers. So that is going to pose mostly a threat for storms that do not possess much supercell characteristics. And if it continues sagging throughout the day, it is going to whittle away some of the potential moist sector that we do get. Dry line is actually a pretty easy one. The mode with your shear vector roughly at a 45 degrees to more 90 as this is suggesting, especially because we have a stronger low-level flow, which is going to kind of keep that, what am I trying to say, storm motion kind of more, let me think about this a little bit. So we noted that our flow in the upper levels was a little bit more at a 45 degree angle, and our shear vector is more at a 90 degree angle at front. And that's likely because our low level flow is, our surface flow is a little bit stronger. So if I pull up a photograph here, sorry about that little rant, but this does not look representative. Oh, it's because it's at 17Z. Let me scoot out a little bit more. Yeah, so when your surface flow is a little bit stronger, that kind of mixes out and shortens your low-level hodograph structure and keeps your deep layer shear vector a little bit more west to east. So that was a little bit of a tangent, but I'm back. I just want to know what was causing that. But as long as you have that deep layer shear vector roughly east of the boundary, you're going to get a mostly discrete mode. Um, Perhaps not that ideal 45 degrees, but you can see there is a significant portion of your shear across that boundary, which is going to mean that any incipient updrafts formed by that dry line circulation, again, this is a circulation, so we have that warm, moist air rising on the eastern side and then sinking on the western side. And if any updraft is allowed to stay on that dry line for a long enough period of time, it is going to eventually mature into a splitting storm complex with that strong shear, and then produce a right and left moving storm half. So our splitting supercells may be slightly a concern today. So we will have to see how that evolves. But as they move into the warm sector, let's take a look at around. It's about when initiation should be. Plot one just north of that dryline bulge, which is typically the maximum area of circulation. The result is this strong low level flow, as we were talking about earlier, actually kind of shortens the hump to your hodograph. So you'd ideally want a little bit of a weaker surface flow in order to attain your best hodograph shape. But I guess a unique feature about this hodograph is that we do have some pretty strong 0.5 to 3 kilometer flow here with this long segment here. And then we have significant venting left of your storm ocean, pretty strong venting at that. So these could be relatively low precipitation storms that form off this dry line, as well as being incredibly efficient at producing hail because you have a very strong, deep layer of storm relative inflow near the ground and some pretty straight hodographs. So this could definitely be a large to potentially very large hail sounding, especially initially with any cells. And then that's not even to mention the cape that we have, which is both pretty heavy in the mid levels and in the low levels. We're rocking 203 3 cape on the sounding. So this could be some bombs of updrafts, and that may be a good thing or a bad thing. Remember, we're dealing with cell interactions here, and then any grouping of cells that fires off this dry line may start interacting with each other. We may have kind of that buddy-buddy system where the dry line initiates right behind another supercell due to the strong uncapped nature, and we end up getting two supercells that or two wannabe supercells that can't really mature because they're feeding off each other. I've seen this scenario, but that really weak LCL LFC separation. As soon as you hit your condensation, you are convecting, and you're convecting rather strongly. Some pretty dry air to fight in the mid levels, but I'm assuming with all this moisture in the low levels, this is not going to be a huge factor in stunting the growth of any storms. So we talked about this hodograph being a little bit less favorable for tornadoes, especially upon initiation. So what would make this hodograph a little better? We could weaken our surface flow a little bit. We could back it a little bit more. And B, we could increase our low-level flow, which would help to create that kind of more classic hump, and your hodograph could look a little bit more like this. So what regime would actually do that is closer to the triple point. Remember, we were discussing the dry line is eventually going to meet up with your cold front kind of up here. So I could go around 22Z and plot a sounding a little bit more here. I would expect the winds will be a little bit more backed here and get some stronger low-level response like we were showing earlier with that low-level jet. That's exactly what happens. We have I can't say that surface wind weakened very much, so that is my bad. But we do have an enhanced low-level jet, as we were showing earlier. Again, I can draw this part out. Let's go to 925. And you can see the response of the low-level jet closest to the low, becoming most powerful as you get closer to that low pressure. So this is kind of the hodograph that results a pretty decent hump in the low levels and some strong speed shear. and as well you still have that strong low level cape and deep layer cape as well. So looking holistically, even upon birth, in closer to the triple point, um, this is a strong to potentially even intense tornado environment, as well as large to very large hail, as we discussed. So any chasers, especially targeting near the triple point here, should be alert, especially early if any storm were to form. I'm assuming it's kind of an early bird gets a worm scenario, because this environment would be theoretically exceedingly favorable for quick supercell development, and tornadoes, especially with critical angles approaching even 70 here. Um, should allow for some pretty non-hesitant low-level mesoformation. So, pretty interesting target up there. I would assume the looks like the low-level flow may start getting better in general throughout the day, closer to the kind of dry line targets. We could select a. I'm using supercell composites just to look at where I'm targeting here. About 0Z, we could take a look at the dry line target, which I'm assuming to be closer to the Red River and in Texas. And we seem to have a little bit better of a hump here. Looks like our surface wind actually did weaken a little bit throughout the day, so that's likely just a response of diurnal cycles. And it has that significant bag in the upper levels. This is a very good sounding for those long-lived, kind of discrete lower precipitation supercells. So this could be a pretty rewarding target as well. And the last target, or the last kind of initiating factor we had was, again, that convergence zone. Now, I've noticed the wrap send out this little impulse. Let's see if we can see it here. Yeah. And I don't know what this is a result of, and I'm not going to spend enough time here forecasting this. But we do have a little impulse moving its way through around the noon hour. You can see kind of those winds doing some funky pattern here. And that is what I've seen the convective allowing models initiate off of, is this kind of wave here. And again, that would be initiating off of that convergent zone in the low levels. Let's see if we could actually find its presence currently. I'm betting we could. It's so mucky here with all those clouds. We could do a low level water vapor. Not sure if that's going to help us. Yeah, because we're all covered by the subtropical jet. So this is going to be kind of a feature where you likely track some low-level, potentially elevated at first showers, working their way up through kind of the Houston area and up here. So we could take a look at the profile. I'm guessing with, let's even work our way up to 700. Guessing there's some pretty deep moisture here. Not exactly as much in 700, but because you're in that proximity to that convergence zone, what I've noticed these past few events is that you have that really deep, icky, moist layer. So even if we have a decent amount of cape here throughout mid-afternoon, I could pluck a sounding kind of in that general East Texas area. And yeah, so you got that gross, 77 over 74, and even a stout cap. We've got some pretty, I guess I had lapse rates up here. We've got some pretty strong lapse rates here, and these could be traced. Looks like more along the Mexican plateau, and it looks like our warmer temperatures are more toward South and East Texas with that. So not surprising that you're getting that warm nose, especially centered around 700. But our photographs look good for sure. This is just the type of sounding. We've got a lot of cape up here, so it might be able to overcome this dry layer and this static stability near the ground. Again, there's not much cape or not much mixing between the ground and the 700 millibar level. So any convective gusts are going to have a hard time reaching the surface with this, even with this much cape. So there could be some kind of balancing act. You could get the occasional strong downburst with this. Tornado threat, I'm assuming with this kind of target is going to be quite low because there's not much stretching to be had in the low levels, even despite pretty crazy looking photographs. And I think these get even crazier as you move east with that increase in your mid-level flow as the system starts kind of scrunching together. Um, with that subtropical kind of gyre here. So I could pluck a sounding kind of in that max. I got too many tabs open. This bugs me. And yeah, your photograph is, they get pretty wild as you go throughout the later afternoon. But again, even though you can register some pretty high supercell composite sigtors here, 2.3, all that is just CAPE centered above like 600 millibars. You really don't have any CAPE below that. So you can have the biggest photographs in the world and really not be able to do anything with that kind of a stable layer. So I guess for this, I would mainly think our supercell, like you will have rapid organization of those kind of super showers into supercells with that really strong low level inflow. May get some rather large supercells too, but this is the kind of event that you just get a lot of heavy rain with these supercells, and they're not. They often are not particularly dangerous. May get some small hail in there, but this is our thermodynamics are really going to hinder much of a threat for any of these supercells out here. And accordingly, I think I remember the SPC outlook really dropped off in risk for all hazards kind of out here. So we'll be interested to see what is going on today. I feel like I was on my game with this discussion, so I'm gonna look forward to following this, and could be some interesting weather out there today. So if you are out spotting, I know Oklahoma is a rather popular area to do that. Stay safe and have fun, learn a lot, and thank you for watching. Have a great one.